Hello everyone, welcome back. Tonight I figured I would kind of continue on. I got a lot of feedback from people after the last stream that sort of the more training content focused on different concepts, specifically around WPF, maybe some more advanced C# related stuff would be beneficial. So I thought tonight I would start with doing some, app architecture and dependency injection related bits with WPF. So I figured I would take one of the existing apps. So if you go back to my previous few streams, I built a WPF app called Color Kraken for tweaking the themes of your Git Kraken client, which is great and cool and awesome. I love it. But I figured I would convert that thing over to doing a better architecture style. It was definitely written in a quick and dirty, go as fast as I can on stream style mentality. But I figured it would be a good example of a real looking application to actually start to convert over and look at the benefits of it. So, powwow here real quick. Boom. Okay, so that is not useful. That's more useful. And let's go bigger. So, for those people who want the repository, we'll drop a link if you want to follow along. If anybody's catching the recording of this on YouTube, just be aware I've probably already pushed these changes, so you'll have to go back in history if you want to start from the beginning part. So let's pull this guy up, and why not have it open? Nope. As you can see, my preparation was minimal. Let's go through and just take a quick look at this application and look at sort of some of the problems that are built into it, because I very conveniently built in a lot of them. Hey, Justin Bieber, thanks. Good to have you back again. I was going on some of your suggestions around doing more kind of architectural design of this, so hopefully something like this will be useful to people. So, okay, so this app here is, I won't say overly complex. As you can see, most of the files, this is a very flat structure. Well, who needs namespaces? Put everything at the root, right? So there's a bunch of stuff here, but the main window here is the primary UI. So we'll just fire this guy up. Come here. Where you at? There you go. Drag. Using a mouse is hard. Tell about them later. Awesome. Seriously, I've been keeping your ideas on a list, so please feel free to shoot them at me. So main window, it's got a group box, it's got a list. There's some stuff in here. This is great. We can change colors, do that, manage our different color profiles. Everything's great. From a code perspective, the main window in its code behind, not in its code behind. Collapse this. Where is your data context? Collapse the resources. So the data context for the main window is just set straight in the XAML. So there's nothing fancy about it, just directly creates it. So this will just invoke the default constructor, and everything goes. So comes in here, default constructor. You'll note that it's got a static property for this iMessenger, which is one of the things we're going to clean up. Builds up all the related bindable properties, a bunch of stuff in here, and that's all well and good. We get down to where we actually create, or was it down here somewhere? Let's see, the new theme view model. Nope. Color picker view model. One of these view models in here. Okay. I've already lost track of my own code. This is how disorganized this is. I can't even find my own stuff anymore. Where was this messenger reference? That was the other one. I'm sorry. In this theme object, or I more specifically, this is just a record class. We end up having to reference that messenger property directly, and things start to get very coupled and a mess. So with dependency injection, there are two kind of main problems that it aims to solve. One, this coupling problem, because without things like dependency injection, you start to run into this situation where things get linked together. So what I mean by that, this theme color class is tightly linked to this messenger property in my main window view model. And there's not a great way for me to break that link. This is just a static property. Statics tend to make things tightly coupled together. The other thing that people often forget about is when you invoke a constructor, that's actually a static call, or it's the coupling equivalent of a static call. So when you new up a new object or class, what ends up happening is that allocates some memory, and then the constructor gets invoked for you as a method. But all you did was new type name, which is great, but the class that's newing up the other class, those two things are now tightly coupled. If I say that, hey, okay, I don't want to use this static property more, I'd really like this guy to take in an iMessenger. Let's see. That way I can get away with something like this. I now have to start walking my way up the food chain. So I have to go, okay, that's now going to cause a compile error. Where did that guy go? Thinking, compiling, preview, compiling. Boom. So now I realize, okay, everywhere where I instantiate this, I have to make sure I pass in an iMessenger, and this thing just kind of starts to propagate up. This is a fairly small app, so it's only nothing in here is going to propagate more than maybe a couple layers, but it's still going to propagate. You can imagine in a much larger application, this problem starts to get really problematic. The other thing that that this coupling ends up doing, because things are so tightly linked, it makes testing the application really hard. And by testing, I don't mean starting up the app and just clicky all the way through the thing's test to make sure it works. We'll call that manual testing. But automated tests tend to get much more difficult when everything's tightly coupled. Dependency injection helps resolve those things and gives you, I guess, clearer lines where you can shear things off. So let's look at means of doing it. We're going to look at implementation first and then go back to theory. Oftentimes I do theory first, but I'm feeling funny tonight, so we're going to go backwards. Okay, so web developers have had it nice for quite a while. So if we do generic host C#, the docs page for this is actually rather nice. The ASP.NET folks, they kind of started down this path back in the early .NET Core days with this idea of building out a web host builder. And then it became apparent that sort of generalized pattern, that what people were wanting was some sort of hosting thingy that could give any app dependency injection, logging, configuration, some sort of service implementation, handling shutdown. All of those types of things are pretty common across a lot of different apps. They're fairly common across even WPF applications, console applications, all of that kind of stuff goes hand in hand. So what ended up happening is now we have this generic host that we can use. And oftentimes people forget about this. Inside of WPF predates all of this. It was not built with this generic host in mind because this did not exist. There's been a lot of frameworks that have come along. Prism's the first one that comes to mind, that attempt to work around the fact that WPF was built before a lot of these nicer patterns were really in existence, and to give you that kind of nicety behavior. But you don't necessarily need to go down that route. What I was going to do tonight is actually show using sort of the in-the-box, they're Microsoft NuGet packages. We'll call them first-party NuGet packages, to go through and get that sort of same setup in your WPF application. For people who have done or played around with Maui at all, I know I've talked about it a bunch on the last couple streams, this is going to start to look a little familiar because the way they've structured the DI inside of Maui to be able to create your views and your view models and all of that, it's going to look really close to what we end up building here. So we come in here, and for people who have done ASP.NET Core stuff, these couple lines should look remarkably similar. If you do file new project on the web stuff, you'll get a program CS that looks kind of almost identical to this, or pretty close. It'll have some ASP.NET bits in it. But this is what we're going to start with. And the first thing to note is that this is going to require setting up a main method, which is the typical place to do this. Now, inside of a WPF application, we don't usually write main, right? We are just used to letting the framework handle all of that for us and say, nah, get us the main when you want. So we need to start with actually getting ourselves a main method rather than using the auto-generated one, because WPF will auto-generate a main method for us, which is great, but that's not actually what we want here. So I'm gonna move some stuff around, because I cheated at this and did a little prepping ahead of time because I felt the urge to do that. Okay, so let me make sure. I'm gonna just revert my current changes real quick so that we go back into a working state, because I'd like to be in a nice compiling state and then we'll break stuff. Okay, so let's take a look at what we want to do. So I typically, when I'm going to do this, you can go and put it in a program CS if you want, but what we need to do is actually create a main method. So just like you would in any other app, public static void main string args, boom. And actually we're gonna just blatantly steal all of this. Guess I didn't need to write that if I was gonna copy and paste it. So we're just gonna take all of this. Okay. And then I guess we actually need the NuGet package for this. So something Microsoft. Let's look at the docs. I think that those are probably the easiest place to get it. Microsoft extensions hosting. That's the magical NuGet package we want. So let's go here. Boom. Let's turn off preview for the moment. I would like to browse that one. Pretty please. Great. And while we're in here, we're going to grab the dependency injection one too. Dependency injection. So and I will call out, you want the dependency injection ones, not the abstractions library. So this is kind of the base classes. This is the one that adds the Microsoft default implementation. With the way that we're going to set this up, because this dependency injection is built on the abstractions, if you do want to plug and play a different dependency injection container, there's lots of them out there: Autofact, Inject, Unity, Structure Map, etc. All the major DI container, they all have packages that will let you work. Sometimes they'll call them ASP.NET Core dependency injection. They're not actually usually tied to ASP.NET Core. They're usually tied to this dependency injection abstractions, and they'll usually just give you a nice extension method that you can fire up and do. Okay, now that we got the NuGet packages, we should be able to get the using statements loaded up. Okay, and then the first thing we're going to do, we're not going to have a hosted server, so we're going to get rid of that. Okay, so we've got our main method, and let's go through, and we now need to change up where this goes. So if we go into here, so just right click on the project, go to properties, and then startup object. So you'll note, not set is typically where you want to go, but you can define your own entry point. So in this case, we are going to set it to here. So once I've written the method, it's able to find it, and it knows, hey, you've got a custom one in here, which is great. Now, if I fire this up, this is going to fail because this is not actually what you want your main method to look like. This is fine for the generic host bits, but this is less fine for actually getting a WPF application to go. So let's actually look real quick. I'm going to go back here and turn this guy off. Let's just go into the CS proj. So I can comment this out. And let's look, because once you write your own main method, we shouldn't write a main method and then, okay, so my main method is commented out, just to be clear. Okay, so then you can pick your favorite decompiler. I currently like dnspy, but That may end up needing to change as dnspy appears to be not getting much maintenance. Let's go. Let's just look at what this main method does. If we go bin, debug, compilation, and then for WPF apps, you typically want to go after the DLL, not the exe. That is the exact opposite if you're compiling for framework. Everything will be under your exe. Okay, so if we go and look in here, what we are hunting for is the main method. And the generated main method that WPF builds, they actually put inside of that app class as well. So there's a couple things to note right away when we look at this main method. First of all, the code that we actually want to do is instantiate a new app object, call initialize component on it, which is actually what's going to run through all of the generated XAML and get all of that set up for us. So you'll note it loads up the app.xaml file, sets the startup to our main window, and gets all of that content loaded, which is great. And then it calls run. And this is what actually makes a WPF application go. The other key thing that it does is it sets STA thread on top of your main method. This is important. There are two types of threads, STA and MTA. I won't dive into them too much. Feel free to Google around. The short version, STA, is for UI threads. MTA is not. So that's the 30-second implementation. But what we want is we want this code here because we want to make our main method work like a real one because we actually need to start up the app. Okay. So there's that. But we now need to kind of separate some of this stuff apart. So let's see here. We want to not necessarily do this because this run call will be blocking. This run call is also blocking. So we kind of have a bit of a mismatch of what is going on here. So first thing we're going to do is we are going to do, let's see, an iHost. And then let's break apart the run calls because that's ultimately what's going to be problematic for us because we want to build up the host so that we can get all of the benefits of our host builder. And then that's actually a disposable guy, so we'll put him on a using statement. Clean up our app. Target type new. We're on new C#, so we can get away with that. And then rather than calling run on here, what we're going to do is call host.start. And then we also need that STA thread attribute on there because we need our method to behave. We need our method to behave like a real WPF app. Okay, so we've created the generic host builder. We've started it so that it will have done all of its setup stuff. We'll then do the regular WPF-y stuff, and then we will call go. The only other thing that's not really going to be handled nicely for us here, actually, let's fire it up. We might be able to get away with this. Let's see. Yeah. Oh, program has more than one entry point. Did I not set that up? There. There's the entry point. Okay. Close all but this. Boom. What'd I miss? What did I miss? Oh, that's what I missed. Look at this sexy programmer. James. So, my comment a moment ago about how the app.xaml is what WPF uses to generate that. What actually triggers the generation of that main method is the MS build type of this guy. So unfortunately, by default, you don't see it in your CS project because it's just on by default, which is convenient. But it's actually this guy here, this application definition. By having it be an application definition, that causes it to generate the main method. So what we want to do here is downgrade this guy to page, and of course it's gonna be dumb. So we're gonna cheat. So I think this might be a VS 2022 bug because I ran into this before. I don't know why. So you'll note it turned off the application definition, which is great, but it did not add it to the page set, which is ultimately what we want. So because we still need it We still need it to be run through the XAML compiler so that we generate up that initialize component method, but we don't want it to be treated as an application definition where it also generates a main. XAML spelling counts. Okay, now let's try to build this guy. Huzzah! Okay, let's launch it and just make sure that our app still works, because hopefully it should. Okay, app is started, we're happy, we're running. We've gone through the effort of actually setting up this generic host builder. So we haven't actually gotten any DI set up, but we do have at least the structure of the app going. And you can use this generic host builder pattern in any of your apps. The one other thing I will call out that you should not do in C# 7.2, 7.3, 7.1, late 7 range, Microsoft added the wonderful ability to do async main methods. The problem, if you do this, because this is great, because you'll know there was like start async and whatnot on here, which is great, because now you can write this. This doesn't work. And specifically, what does not work here when you do an async main method is this STA thread. Yeah, you'll note the calling thread must be STA because many UI components require this. It requires us to go through and set up the STA thread. Well, once you do an async main, this no longer will get applied to your entry point. So that's a problem. Don't do that. So, short version, for WPF applications where you need to set the STA thread attribute on top of your main, do not make it an async main because you will not get an STA thread. Okay, so let's go through and actually get this set up. So, let's talk about a little bit about what the dependency injection is. So you'll hear people use the words container a lot when referring to dependency injection, because dependency injection is basically like a recipe book. So you can imagine if you want to build something up. Let's imagine, and just ignore code for a moment. Let's pretend that I actually know how to cook and that I would like to make a cake. When you go to make a cake, it's going to take a bunch of things. I'm going to need milk, eggs, flour, lots of sugar. Sugar is important. All of these ingredients or pieces go in, and they're a dependency of actually being able to build up a cake. So what your DI container is effectively a recipe book telling you, okay, where do I find the milk? Well, hopefully in the fridge, right? Where do I find the flour? Probably in the pantry. Those types of things. It knows all of the pieces that it has, and so when you say, I would like to build a cake, it goes, got it. Let me look up the recipe for cake. Okay, cake takes the following things. Let me go get those things. If those things have other dependencies of their own, let me build those up, and it just kind of recursively gets all of that stuff and then hands you back a cake, which is great. So that problem that I had mentioned earlier where, hey, I want to add in an iMessenger so that I don't have the static property, now that whole recursive nature of needing to add it to all the constructors all the way up, that now goes away. We now have a way of creating things. We simply ask our DI container, hey, I want one of these things. Please give it to me. And it's responsible for giving it to me, whether that means creating it, giving it back. The other thing that it can do is manage what's called the lifetime of your objects. Because some objects, for example, your main window, oftentimes you'll probably want only one of them, hypothetically speaking. Some objects you may want multiple instances. Maybe you've got some sort of like pop-out window and you want to be able to pop out multiple instances of these things. Great. Your DI container can help you manage. When you say, give me back a cake, you can set up the lifetime of that cake to either be, okay, I only ever want one cake. We're not going to make a bunch of these. For the birthday party, we're doing one. Or you can say, you know what? Every time somebody asks for a cake, you get a cake, and you get a cake, and you get a cake. That works too. You can start to do that kind of centralized management of all of your dependencies and resources. That's one of the nice things that the DI container gives you. The other thing it can do, and we'll see how far we get tonight with it, is once you start structuring your app for those, for the DI container to be able to build those up, you can start doing what is referred to as inversion of control. So you start inverting how the stuff is structured, which usually involves having your object constructors taking interfaces, your objects built against the interface, and then that helps facilitate testing, because now rather than having to create all the things for the cake, you only need that first layer. So only the immediate dependencies for a cake are what are after. By the way, watch your Calamity stream and the C# building custom controls. Very interesting to watch. Oh, thank you very much, Justin Bieber. So, shameless self-promotion time, because for people who are interested in those ones as well. So the Calamity stream is actually hosted. Oh, let's go back to the beginning. The Calamity stream is actually hosted by my on the company I work for, their YouTube. So feel free to check them out. They host all of the local user groups, and so we've been trying to do recordings and get those posted. That was one of them. It took a while to come up. So if you are interested, that one I had a lot of fun doing and building out. So if you want to see fun ways to abuse C#, hopefully learn something. There are good techniques in there. It's just I take a useful technique and go to as extreme off the end of the thing as I can. So also, for anybody watching, there's my YouTube channel. For those people who need it. Oh, it's also, right below me. There's that too. Okay, so let's look at actually setting this up. So DI containers, being that recipe book, are fairly stupid. They do not magically know how to make a cake. They do not know how to instantiate any objects you don't tell them about. There are the non-Microsoft DI containers oftentimes will add in functionality that uses reflection. So it uses code to examine all of the types in your assembly and just automatically register them. That reflection comes with a hit, because that takes processing time to go and do, but sometimes the convenience of making sure your DI container knows about all your classes is worth that hit. So it's up to you to decide if that's a good idea or not. It's something you can do. The Microsoft one by default doesn't do it because it wants to be performant. You have to tell it about all the types. If there's something you care about, you have to add it. So how we end up doing that. In this configure services, this is effectively where we are going to lay out what goes in our recipe book. So in our case, we are going to do services, add Singleton, and then we're going to start with our window because we would like it to instantiate windows. And you will note it doesn't know what add Singleton is because it's an extension method. So for those people who missed it, using the namespace here, if it helps, the name of the two NuGet packages we added are the same as the using statements you need here to be able to do this. Okay, so our thing now knows how to call the constructor of our main window. So if we tell it, create a window, it will go through and invoke the constructor. Now currently that's easy because right now our constructor is a default constructor. Any DI container can figure out how to invoke a default constructor. It gets a lot more interesting when we say, okay, by the way, I want you to actually pass in my view model. And so now what we're going to do, and actually let me put that property back real quick. We're going to keep the property around for a minute because that's actually mildly helpful. So let's go here, and what we will do is we will go data context gets view model gets view model. Okay, so we'll take the parameter and just assign it all the way through. Technically this does two assignments, this to here, not necessarily in there. Any type at any nesting level can get an instance or only top level type. Any type at any level. And we're going to get into doing the nested instances because our main window view model creates up that theme object, and that we want to be able to get this messenger in here. So we'll get to that in a minute. So as soon as we do this, now it's gotten interesting because in order for the DI container to instantiate the main window, it needs to know about main window view model, which currently it doesn't. So let's add that too. So we'll do services, add Singleton, main window view model. And in case it's not clear from the name, add Singleton means that the DI container is going to have one of these. So it'll create the main window the first time, and anybody else who asks for a main window is going to get that same instance. So Singleton, single, one, done. No thinking. It's worth noting that oftentimes singletons, what may be a singleton in your running application, may not be a singleton when it comes to, say, running it through unit tests, because unit tests, you oftentimes want to run them fast in parallel quickly, which means you can't have one thing, which means statics, not so good, because then things can't run in parallel. But for a running application, in this case, we're saying, you know what, main window, we only want one of these things. Okay, and so our main window view model, this guy here, I believe, still has a default constructor, and we're going to leave him this way for now. We're going to change up this messenger in a minute, but right now, let's actually get the app working with just the DI container creating both of these. Now, the first problem we run into is initialize component. Add singleton thread safe if I ask it many times at the same time. Great question. So it's worth add singleton, I don't think so, but it isn't going to, but the add call isn't going to be run on multiple threads. So specifically, this is going to be evaluated at the point we call build. So your DI container is expected to be built up once at the beginning of your running application, and then the calls to getting things out, those will be thread safe for you. So that's where it actually matters, because typically getting the instances back out, this guy can lazily, it's not going to instantiate a main window at the point where I call build. It's going to wait to instantiate main window until the first time I ask for an instance out. So, and that part will be thread safe for you. So I don't think add singleton is, because I think the implementation for almost all of these add methods is just putting things into a dictionary or similar. There's a bunch of nesting in here, but ultimately it comes down to what adding a service descriptor, which I think those go into a list. Regardless, this thing I don't think is, but I don't think the add call itself matters, just the retrieval. But if I ask for the first time many times, that will be thread safe. So if you run into a situation where you say, give me a main, so after you call build, and actually we're about to do it here real quick. Let me show that real quick, because I think that will hammer home what we're doing. So what we actually want to do is we actually want to get the thing out. So it's going to be host services get required service. So there are two methods on here that are worth noting. There's get service and get required service. The difference between them, get required service throws an exception if it gets back a null. Get service might hand you back a null. So for what it's worth. So, but what I think you're proposing here is what happens if I put this off in multiple threads and call get service multiple times really quickly. You'll still only get the one instance. This guy here will be thread safe for you. This guy I don't think is. But again, this guy should be done at build time, because you really can't start running your app until after you've gotten the host for your application up and running. So for what it's worth, which is another reason why the Microsoft DI container doesn't necessarily do that reflection, iterating over all the types in your assembly, because that would add startup hits. You ask it synchronously. Correct. But for example, if I were to do, let's see, parallel for each, and then let's do enumerable. I don't have any of my using statements in here. Stop helping me. Repeat and 0 and give it to me, I don't know, 100 times, right? And then we're gonna just throw that guy away. But I think this is what you're proposing. So if I do this, I think the question is how many times is main window going to be instantiated, right? Because this is now going to spin up some number of threads, probably 10, based upon what I know about my system, and start hitting this very rapidly. So effectively giving those two calls simultaneously. Here we can do proof inputting, right? Private static int count, and if interlocked increment ref count, and does it return the incremented value? I can't remember if it returns the incremented value or the previous. Returns the incremented value. Perfect. If this is greater than 1, breakpoint. Right, so that'll get us in here, and so this should. I'm gonna leave this here. We'll come back to it, but I've got it set with a breakpoint. We'll prove this out. But we have to change out our initialized component first, real quick, because what's wrong with this right now is the startup URI in our app.xaml is set to main window, which is fine, except for the fact that we don't want WPF created in the main window for us. We want to create it from our DI container. That way we can deal with dependencies. So step 1, we're going to just get rid of that because we don't want that. I don't know why that's up on the same line. So we'll clean that up. So what we want to do instead is we want to actually go through and create the main window ourselves, just like WPF would end up doing it for us, and then building that out. So what we want to do here is app.mainWindow gets, I'm just going to steal this. Boom, boom, boom. So we will grab the instance there, and there's a fun little bug in here. Well, it's not a bug. It's by design. I think it feels dumb. But when you manually do the main window, you have to make it visible. It's kind of dumb. It's something that when it would pull it out via the XAML, it would do that for you. When you do it in code, you got to do it yourself. So, it's annoying. But that should be enough. I'm going to move this down below the 4H. It doesn't really matter. Okay, now we should be able to launch the app, and we should be able to confirm that we don't get multiple counts. Fire it up. Oh, and we run into a lovely little problem where I'm trying to instantiate a UI object on a background thread, so my world falls apart. So that's exciting. You know what? I'm gonna just comment this out and not think about it. There should only be one reference to it anyway. So we're just gonna do this for the moment and not worry about it. I am okay, fine. So when I'm calling that parallel for each, it's doing it on a background thread, and creating a window on a background thread, no bueno. Let's do this instead. Rather than doing it, we can prove that we don't have to prove it with the window class. We can prove it with a different class. So let's do it with a different class instead. Let's go back here. Boom. Because we can just do it. Because it was the main window where we did the count. So let's just move this into the view model, and we'll do it on the view model class. Because the view model was also registered as a singleton. So we'll test it on that. Message queue. Bah humbug. The message queue is still, I uncommented that thinking that was inside of my window, and it's not. So hang on. We can prove this. We can prove it. We can prove it. And there we go. So app launches, and let me just make sure I had my breakpoint set on that. Well, of course I didn't. Try this again. Oh, hello, Houston. Oh, that's exciting. Where? Oh, that's why. Okay. Whoo! Whoo! Okay, I was like, something is not jiving with what I know. We missed a change. So the fact that I saw that the call stack went through initialized component meant that it's being done here. We got to take it out of our XAML. Okay, we only want to do it in one place. One place is good. One place is good. Let's try this again. Try this again. I was going to be very shocked because I was like, I'm pretty sure that's problematic. Okay, now it is working as expected. Woo! Something scared me. It's like I'm very confident in this. Okay, so view model, only one instance was created. We never got inside of our increment more than once when we were only creating it via the DI container. So, yeah. So yes, the get service and get required service, those things will be thread safe for you. Those are handled. So you don't have to worry about, somehow getting multiple instances of something you declared singleton, because certain objects, like maybe a cache object or similar, you probably only want one. Okay, so muchos better. Great question though. So I'm going to turn that off, because in C# you don't have performance problems, you have memory problems, and memory problems. Okay, let's talk interfaces then. So specifically this messenger. So this is one of the ones, and initially when I had done this, I did the messenger class just as a static property because I needed to share it, because in this situation, this messenger, all objects for this thing to work need to get the same instance. So for people who may not have seen this before, this is something that comes from the Microsoft MVVM toolkit. It's effectively a publish subscribe model, or pub sub that you'll hear it called. Two things get a hold of it. One piece of code sends a message, another piece of code can register up for a given type of message, and then all the people who registered for it get it back. You can kind of think of it like a distributed event. Some people call them event hubs and similar. Right? This is just kind of a small in-memory one, because oftentimes in your application, you kind of need that small distributed messaging. Things like Xamarin Forms and Maui have a built-in class to do similar. In the MVVM toolkit, there are a couple implementations of iMessenger. One is the weak reference messenger, which, as the name implies, if you register for a message, you have to pass an instance to yourself to say, hey, I want to know about messages. And this guy here only maintains a weak reference, which means if the messenger is the only thing holding a reference to you, you get garbage collected. This reference is weak. So, and then there's also another strong reference one. I tend to favor the weak reference one. The MVVM Lite library that this was based on, that was how that implementation worked. That's usually how I build my code, with the idea that registering for a message is weak and not going to hold a strong reference to me. If you use the other one, the strong reference one, you got to make sure to unregister so that you get garbage collected. So, it depends on what you're doing. You can pick your favorite. This is my preference though. So, but the fact that this thing needs to be a singleton and shared, that doesn't need to be weak reference events slower than common events. So the pub sub model can certainly be slower than regular events or common events. Because C#, if you use like the event keyword, what that ends up giving you is what's called a multicast delegate. It's effectively a delegate object that's actually a list of delegates. And when the event gets raised, it just goes down the list and goes fire, 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 fire. This one here, I don't know if they necessarily performance tested it against a regular event, but there was a bunch of work done. Shoot, I am blanking on the guy's name. At the time, he was an open source contributor, but I believe he now works for Microsoft on the project. But when they rewrote this from the MVVM Lite library, they did a lot of performance tuning, and so the API for the iMessenger is a little different than MVVM Lite. It's a little more obnoxious, but the performance gains were like 100-fold. It's insane. So this one is fairly performant. Can we build all applications only on weak references? Yes. So in C#, the weak reference, there is just a straight up weak reference class that you can use to hold on to a weak reference. It is the only thing with a weak reference, and you can build things up that way, right? So this, by default, everything's a strong reference. When the garbage collector is looking at your app to figure out what objects aren't being referenced anymore, these strong references are, how it follows down through the tree to know what it can clean up. Weak references don't count for that. So those references don't go across. So you can build an entire app on weak references. The problem with it, and I think oftentimes why the weak references being slower, it comes into play, is then every time you go to access it, you now need to check and make sure that you actually got something back, and that weak because you have to first take that weak reference into a strong reference and then invoke on it. There's now 2 steps where there used to be 1. I wouldn't build an entire app on it, but I definitely build entire apps on just using the weak reference messenger. So let's come back to our app.xaml and let's add that guy in. So services, add Singleton, because once again, this is something I only want one of, and I want it to be an iMessenger. And specifically, the implementation that I want for that guy is going to be the weak reference messenger. So we'll slap both of those in. And sometimes I like to move this configure services and the host builder off into its own class. You'll note that the registration for these services, oftentimes this means you get a using to like every single namespace in your app, which is quite common. Because again, this is the recipe book for all the stuff we're going to build up. So this thing can kind of get fairly large. And definitely test this. We'll see if we get all the way into writing a test library for this. I'm hoping we do. Because that shows off the other big part. And I want to be clear on something too. If you are just starting out on WPF, I wouldn't tell you to jump into this first. Just like when I was talking about the MVVM, if you're just learning WPF, just get the app working first. Get something small, up and running, make sure you're familiar with XAML, get yourself over that learning hurdle first. Then tack MVVM on it, get over that learning hurdle next. Then start to bring in some of these more advanced concepts. If you try to bite the whole thing off, there is a very steep learning curve, and if you aren't familiar with a lot of this stuff, that's a lot to chew off at once. Take it in bite-sized pieces. Highly recommend it. Okay, so we've told our DI container about iMessenger, which now means we can come back here and we can sort of get rid of this guy here. We'll eventually kill him off almost completely. But this guy, this messenger here, we can now bring him in. So iMessenger. And you'll note, I downgraded him from a static property to an instance. Because in this case, I don't want my view model making assumptions about how many instances of messenger there are. I want it to just trust whatever it's given and use that. So what we'll do first is we will messenger gets messenger. And just for fun, it's not reasonably possible for this to happen, but we'll just make darn sure that we don't get a null. Because I'd rather get an argument null exception here than a null reference exception here. Because no reference exceptions are almost exclusively programmer messed up. That's pretty much what a null reference exception means always. Okay, so we'll do that. We'll get that built up, and then I thought there was going to be one more case where this guy bit us. Where did that theme class go? You're here. This guy. So now that this guy is no longer a static property, this class here now needs to know about that messenger. So what we're going to do is we're going to just pass it in. Messenger. Spelling is hard. Oh, and we capitalize it. So for people unfamiliar with this is called a positional record. So positional record meaning I've done this sort of declaration up here, right in line next to the class. This ends up doing several things for me. This will generate a constructor with this signature. This will then also take each of these parameters and create properties with them. Which is the reason why I capitalize them, because it looks a little weird because these are used for two things, both the properties and the constructor signature. It's gonna look, the casing's gonna look weird for one of them, because normally lowercase the constructor parameters and uppercase the property names. So I can't have both. So the compromise is make the constructor signature look a little weird and make the properties look correct, because ultimately with DI we don't call the constructor anyway, so doesn't matter. Okay, so now we take this guy in as a constructor and then this guy goes away. All right, so back to where we were, and then if we jump back over to here, we now have little red box here, and this guy here takes in messenger. But I need to make this method non-static so it can access the instance property. Poof. It may be that the injection is unsafe from the point of view. Any developer for anywhere can get everything he wants, although his place of work may not imply work with a certain service, but he gets it. Interesting. I think I would probably, so I don't doubt that there's probably cases like that. But I think that I would use that as an exception case, not necessarily the way I would design it. And I think that might be a little more clear down when we get to getting rid of this constructor here. Because right now, this theme color constructor, this is tightly coupling main window to this guy's constructor. If I go and say, okay, now theme color needs another dependency. Messenger was easy because I already had it. Oh, don't worry at all, Justin Bieber. But if I add another dependency, so you know, my service as a third parameter, now I have to add it to the constructor. But then main window view model needs that just so that it can pass it in here. We want to break that coupling. So we're going to do that in a minute. But let's once again make sure the app works still. So we should be in a good state with the messenger working. Okay. This should work. And then just for fun, what we're going to do is we'll come in here. I think this is set to the same theme, but I think if I change this background here to I don't know if that's going to make a big difference. Yeah, you can see the green color change. So that's the so this apply button is what's triggering that message back out. So I know that my iMessenger instance is working. So perfect, huzzah, it's flying. Let's go back here. So right now I had just been registering all of my services as Singleton. And that is one end of a spectrum when we talk about object lifetime of getting back just one thing. The other side of the spectrum is always create a new instance. So on the other side of it is what we got is service add transient. And so transient is the opposite end of the spectrum from Singleton. Rather than getting one instance, always create a new one. Every time somebody calls get service or get required service, always give back a new instance. I don't know if this is completely clear or not, but even though I'm using the phrase every time someone calls get service or get required service, typically you aren't making those calls yourself. Typically you don't, once you get the DI container set up and you get everything rolling at the top, which is what we did here, oftentimes you won't, so this, like the services property is an iService provider. Typically you won't access the service provider directly beyond that point. This will be the one time, effectively, because WPF the framework doesn't have built-in support for this, that we basically retrieve the top level thing from our DI container, and then we let DI handle the rest of our instantiation for us. And we just go hands off. So I'm saying get required service, but understand that when I call main window, the DI container is actually responsible for calling get required service or get service for everything that my view model actually needs, which is great. That is ultimately what we want to do. So let's change this up, because right now we have this really tight coupling down here to this constructor, and I would like to break that. Well, actually, real quick before I do that, one comment I will make. So there's add singleton, add transient, and those are the two built-in ones. There's a handful of DI containers that if you add them instead, they'll add a little bit more fine-grained control on this spectrum for how often you get a new instance. The other built-in one that's worth noting is add scoped. This is kind of, so if you've got add singleton here, add transient here, add scoped is kind of in the middle. So what this does is, if you were to create a scope, all instances within that scope will be resolved as though they were a singleton. But once you jump out of that scope now and into a new scope, then you're going to get new instances again. So it's a way of basically where you kind of want a singleton but kind of don't. So for example, in ASP.NET Core, when you have a controller, the controllers by default are registered as scoped, so that each request that comes into the server gets a separate instance, because you don't necessarily want two requests potentially sharing data across. That could be bad. And so the controllers by default are registered as scoped instances. So when those come in, each request will get its own instance of the controller. Those get returned. Away we go. Task run build theme. This place runs synchronously. Close. No, and that's actually another thing that I'd like to clean up here in a minute as well. So this is putting load themes, and this is bad practice. So don't trust this. We'll make this better. This was quick and dirty approach. So the problem is load themes is going off to the hard drive and reading all of those files, and that can occasionally be slow. And typically inside of your constructor, you don't want to do large amounts of work. And in theory, you shouldn't do this in the constructor anyway, but this is quick and dirty. So task run, what it is doing is it is creating a task and registering it for the background worker queue to process those tasks. So anytime you have a task, the background worker, I'm not awaiting it, so it creates the task, queues it up on the background worker, so it will start running some point, but it allows the constructor to return immediately. This is oftentimes very bad, because this gets you into the case. This is subtly like having an async void thingy in here, because it's not awaited. If an exception gets thrown up out of this, it bubbles all the way up and then crashes the application. So that's not a great thing. Which is why this thing has an explicit try catch to prevent any exceptions from bubbling out, because I know it's being invoked poorly. In general, you should not do large work in the constructor. That's problem one. Normally, this should go into an async method somewhere else that's maybe invoked after the window is shown or similar. The only two places this gets invoked is when the refresh button gets clicked or at startup. So, but we will pull this apart, because this static call here, because task.run is another static, it is tightly coupling us. And so if we were to try to write tests over our main window view model, this could quickly become problematic. You can imagine wanting to write a test that tests for an empty directory and writing a test that tests loading a single file. Well, that now becomes really problematic, because I can't control that anymore, at least not in parallel. I'd have to run those tests one at a time. So, but we will clean this guy up. So even though it's not awaited, this still will get queued up and executed. It just means that the completion of instantiating the constructor will finish before load themes does. Okay, where were we going? All right. We want to clean up our theme creation. So the other problem with this theme object here is this constructor contains sort of two types of parameters. It contains something that's going to be resolved from the DI container, the messenger, and it contains some bit of data. And so we now have two sources of where this stuff needs to come from when we instantiate this guy. Because if we look at where we build this guy up, theme new, where's new? This. So if we look here, one of the parameters is coming here, one of them's coming from the messenger, but really we could have the DI container resolve this. So when you run into this kind of situation, which is oftentimes one of the first things people hit when they start using DI containers, is they go, well, hang on, my constructor has data and it also has DI stuff. Now, one option is refactor your object such that that's not possible, right? You can see value here isn't a problem. It's not going into the constructor, but color name is. And so if you can reasonably refactor your object, fine, go for it. But in this case, I would say it really doesn't make sense. We only want to set this name once, and we don't want to do it again. We don't want to have this situation where this property exists or could be assignable. We want to keep the nice immutable record that we have. So the generalized pattern for doing this is what is called a factory pattern. So rather than having the DI container necessarily know how to create theme colors, what we do is we tell it how to create a factory for theme colors, and then we will use that. And that way a factory can take in any amount of dependencies that we have, and it can deal with kind of crossing that boundary. Now, I'm going to do this the long way first, and then we're going to clean this up. So a naive implementation might look something like this. Factory. Okay. Get my mic out of the way. So, and we're gonna do theme color. We'll call it create string name. Okay, so we'll have a theme factory, and then so this is a lot of code. There's a one-liner we can do instead. Oh man, the auto code is so strong. Okay, so we've got this method here, which is great. I'm just going to expression body this guy. And typically when you're writing these factories, the factory's job is really just to call the constructor. He is basically the glue that allows you to link incoming data with DI dependencies. So we do this, and we do messenger. And then we come over here and we go, well, where are we going to get the messenger from? Well, we can come in here. We can do messenger, autocode a property for me, please. And now I've got a nice, easy way of doing this. So I've got this nice themed factory. Great. So there's a nice interface here. I'll explain the purpose of this interface here in a moment. But you'll note calling the constructor for theme color now comes partially from some incoming data and partially from a DI dependency that was resolved from the constructor. Perfect. We come back to our DI registration, and we need to teach it about that factory. So services add Singleton. Theme color factory. So we'll register that up, and then our main window view model, this guy changes because he really doesn't care. All he needs to know is, I have a string, I want a theme color back. I don't want to think too hard. So we can do something like theme color factory, theme color factory. Let's see, create an assigned property. Great. Add a null check for me. Great. And then we're going to come down here. And then rather than calling new theme color here, what we're going to do is we will go colors, add theme color factory, and we'll call the create method. And actually, we might go one step further. Let's pass value in too while we're at it. Let's see. Oh, and it is color name. So this guy's unhappy because my signatures don't match, but let's fix this. What is value? String nullable. How about initial value? We'll have this guy just do the value assignment for us too, because why not? This needs to be added to both the class and the interface. Blah blah blah. That goes there, that goes there, that goes there, and now this works. So that was a lot of code. Let's run it and make sure it works. So this is what those individual lists of colors on the main screen. If we see that list show up with values, we'll know that we were able to create the instances. So if we bring this guy over, okay, so we can see it loaded up all of these things. This is a lot of typing. So just to reiterate, this is a generalized pattern that can be applied in any number of ways. There are shortcuts though. However, it's important to understand the basic pieces of the pattern. So in this case, rather than tightly coupling ourselves to one particular instance of this factory, we put an interface out there. This will largely come into play when we get to testing. This interface here is backed by this particular implementation. But in terms of our main window view model, it doesn't know about the actual implementation. All it knows about is I have a thingy that can create theme colors for me. And that thingy can create me a theme color given a couple strings. Perfect. Easy mode. I don't have to think too hard. That's exactly what I want, because that's all my main window actually needs. It doesn't care how that thing got created. It just cares that it does get created. So if there are any additional dependencies, I've now isolated them well within here, which is great. And I don't have to, in the event that, this guy's constructor changes, I update it in one place. I don't have to update it in multiple places. Perfect. The factory pattern is also a situation where you might actually want to do things like bring in the iService provider, because occasionally your factories may need to do some sort of resolution stuff. Depends on your implementation. But in general, if you do need to have some sort of glue between how do I create objects, there needs to be some custom logic, and I need to do different stuff. Oftentimes a factory pattern works very well for this. It allows you to kind of make that separation and break apart that constructor call. Okay, but I promised there was an easier way to do this, because this is a lot of typing. I do not want to do this every single time. In general, if I can refactor a way to have my constructor not take in data and have my constructors only take in DI resolvable dependencies, that's generally preferable. And the exception cases tend to be things like this that are sort of doing multiple things. So in WPF, I often run into this situation where I'm creating a view model. Like for example, I've got a view model to pull up in a dialog. I want to pre-populate that dialog with some data. And that data really needs to be available in the constructor. I don't want to pass it in later. Therefore, I need to do something like this. So those are the types of situations where I typically run into this. For things like, for most other cases, it's usually better to try to consider whether that data really needs to be available in the constructor or whether that data could be provided later. Is it really a dependency? Is my theme color going to be in an invalid state if a name isn't immediately provided? If the answer is yes, then it really should go into the constructor. If it could be provided later, maybe a property, maybe some sort of init method, etc. I register instant. Let's see. I register instances for all applications. I can get any of them from any place and from any related library. Yes. So anything that you register in your configure services is now available for consumption. So now that I've registered up my iMessenger, if I put an iMessenger in any object's constructor that the DI container goes to resolve, it now knows how to do it. So it's very common in a big application to have, you know, a few hundred of these add calls. So maybe some of them will be transient, maybe some of them will be singletons. Depends on what the object is. But yeah, anything that you can reference by a type name in C#, you can put into your DI container, which is pretty powerful, pretty quick. It also means that when I go to test my main window view model, I can now pass in test doubles for it. And one other video I will call out. Let's see. There is another one that I have called polishing your unit tests. Yeah. There's this one here. Nope, back to the beginning. This is another one. So it's specifically if you're getting into the idea of writing tests and structuring your objects in this way such that they have dependencies coming in through the constructor, I definitely take a look at that. Because when you get to writing tests, that can often quickly become a time sink, and it doesn't need to be. There are a lot of different ways of providing those dependencies sort of in an auto-magical fashion, which is cool. But there are trade-offs to all of the approaches. In that video, I kind of go through 4 basic approaches of just write it by hand, use a library like mock or mockq, use something like AutoMocker to make that process even faster, and then go back to writing it by hand. So it goes full circle, but I try to outline kind of the pros and cons of each. I think outside of the first approach, the latter 3, there are use cases for each of them where they make sense, and it's important to understand their blind spots. Because typically in an app, I'll use some combination of all 3. Typically. There's a few cases where you can get away with only doing the very last one. Okay, so let's look at simpler case. So in the case where we've got a factory where it really just is this sort of pattern. Because sometimes your factories, perhaps we want to have a factory that's even simpler, right? We could say, you know what, maybe we want an overload of this that doesn't take a string, or maybe we have one that takes an int or similar, right? We can start making these factories fairly complex if we wanted to, and adding more functionality to them. But in the case where you really just have a single interface, a single create method, this feels a little overkill, and it kind of is. So a simpler option is to abuse the delegate type in C#. So if we go C# delegate, theme color, and we will call it, just call it create theme, I think. And then string name. The fact that the autocode is hitting on point for this is really creepy. Kind of love it. So, for those people who may not be familiar with delegate types, oftentimes in C#, you don't need to declare your own delegate types. This is something that was really important back in ye olden days, especially when you were defining your own events and that kind of thing. Nowadays, most people just use func and action for almost everything, unless you're doing things with like outer ref parameters. Func and action pretty much rule the day. But the one thing that declaring a custom delegate gets you is that it allows you to put a name to it. And so action and func are great for kind of smaller scoped things, but you could use them in your DI container, but they lose a little bit of that meaning because they don't really have names associated with them. Maybe they're fine in your particular application. I'll leave it up to you. I know one of my colleagues says that he enjoys using func for the trick I'm about to show you. But I think it really depends on context. So I prefer custom delegate because it allows me to do to put a name to it. So in this case, I'm just saying, hey, I'm going to have a method. It's going to return a theme color. It's going to take in a name and an initial value. But the name of this delegate is create theme. What we can do is we can come back over here. Here. And rather than doing theme factory, so this is alternate technique. We can go add singleton. and we can register up a create theme. Now, you'll note on all these other add singleton calls, I just specified the type. So that will let the DI container create it when it's ready. However, maybe creating up one of these types requires a little more know-how, something that perhaps the DI container doesn't know about, or maybe you want to provide your own customization or whatever. But inside of this add singleton method and any of the add ones, you'll note there are overloads. So specifically this func that allows you to get an instance of the service provider. So this will get invoked after your DI container has already been set up. So this callback gets invoked once the first time somebody asks for this thing. So we'll do service provider, even though we don't really need it. And then we will create a new create theme object, which is going to be this guy here. And then inside of the create, so just like we were instantiating a normal delegate, what we would do is we will wrap this up with string name, string init value, and then we will do new theme color. And so this will be name, provider, get required service, messenger, running out of horizontal space very rapidly, and then value gets initial init value. Okay, so let's break this onto multiple. Oh, we're debugging. That's part of why this thing is angry at me. So let's break this guy down into to its individual parts, because this is big. Let's see. Multiple white space to make code readable. Definitely white space to make code readable. So I think we do it something like that. Okay. So what this is doing is it's adding a singleton for this delegate type, and it's saying, okay, when somebody needs this delegate type, here's the instance that I want you to use, because I'm creating a new instance of this delegate. So this is going to be that singleton instance. And it's going to take in when creating a delegate, this is no different than old school C#. We just set it up like this with the right signature. So string or init value, this could just as easily be pointed at a method somewhere if I wanted to put it there, but I'll do it in line here. You'll note then this guy is doing the exact same work that our factory was doing. It passes the name parameter into the name of the theme color constructor, and then it uses provider get required service to actually reach back into our DI container and say, hang on, I need that iMessenger. Pulls it back out and then assigns the value. And what we can do instead then is back in our main window view model, rather than using this theme factory, we can get rid of that guy. And what we can do instead, so I'm just going to comment this out, is we can go create theme factory. We'll do that again. So once again, I'm taking in a delegate, and then I can come down here, and then rather than calling theme color factory create on the delegate, what is it? What did I call it? Theme. What did I call that thing? Create theme factory. Naming's hard. So then I just invoke it as I would any other method. So just to be clear, in case people didn't catch it, the constructor brings it in, assigns it to this property, but because it's a delegate, it just holds on to that reference. And then I can go through and invoke it whenever I need it, as the same as I was invoking the factory. And actually, I'm going to copy this and then undo. Boom. I'll leave them all sitting all right next to each other for the moment, just so that it's clear the different methodologies here. So old school without DI, me writing up a whole theme factory, me doing a custom delegate. So oftentimes, if you have a factory pattern that you're implementing and the factory is simple, meaning that it's really just one method. There's not a lot going on in there. It's really just taking in some stuff, munging it together, and spitting something back out. You can get away with using a delegate type. The nice part about the delegate type is when it comes time for testing, unlike having it being like a concrete instance, because the delegate still has effectively its implementation that you need to define inside of it, because a delegate just defines a signature, right? When I lay out this delegate, it's kind of like an interface in that all it's doing is laying out one single method signature for me. Just pretty much all this is doing. So you can imagine this kind of correlates to the interface name. This correlates to the return value. This maps to the interface name, and then this signature lays it out. Not from new. New is glue. We must hide all types over interfaces. So yes, I like that phrase, new is glue. I've heard that a couple times, and that is exactly correct. New is tight coupling. It glues your stuff together. But in this case, the delegate is being created via from the container. So specifically in here. So if you're asking, can we do something like services, just add singleton of create theme? Not quite, because something ultimately is going to need to know how to create this. And delegates aren't something that have I hate using the word default constructor, but that's the best way to describe it. There's not a way to just instantiate them, not giving them anything. A delegate is going to need to know what to actually invoke, because the delegate is really just laying out the signature. Ultimately, what gets invoked will be either some other lambda or some other method that ends up creating this. So you could end up, rather than putting all of this here, maybe move this bit off into a static method somewhere, if that makes sense. It's up to you. Oftentimes I like doing them inline here because this is quick and easy. And if I want to change things, and because you also have access to the service provider in this delegate, it means that you can recursively kind of reach back into the DI container and get out anything that you need. So if there's something else that your object might need, like in this case the iMessenger, we can kind of reach in and do a little grab bag style of, well, I want the name here, I want the iMessenger from here, I want to grab my init value and call a property setter here and build that up. So this works in the simplest of use case. However, the simple use case is far more common than the complicated case. So I'll put it that way. So it's worth keeping it's worth noting that sort of setup for building out your objects and structuring them. Okay, there's one more thing that I did really poorly that I would like to address. I'm gonna leave this guy sitting right. I'm gonna leave the theme color stuff sitting alongside just for reference. It may be deleted in a future commit, but at least for this. Must we hide all types over interfaces, for example? That is a great question. That is a wonderful question. Must you? No. And in fact, I would actually encourage you not to hide it behind an interface until you have a reason to do so. I think we'll get to starting to write tests tonight, so we'll probably get into a little bit about that. When I'm teaching people about interfaces in C#, I usually warn people that interfaces are easy to write, but hard to get right. So they are very easy to declare. Anyone can write an interface. That's very simple. But making the interface correct, meaning it has the right abstraction, is oftentimes more difficult. And quite often I see people just blindly throwing interfaces in and then copying and pasting signatures around. If you're doing that, stop, back up for a minute and think. Because I don't like the blind hiding things behind interfaces. Oftentimes it's important to note doing it that way does decouple two classes. But if you have a poorly designed interface, you may not have actually decoupled it as much as you think you have. So I oftentimes tell people don't do it. So for example, we don't have to hide things behind interfaces for the DI container to work. So main window is an example of that. There's no interface going in. It's a concrete class. As long as the DI container knows how to create the thing, you're good. It is worth noting too, there's a concept of the type that is the implementing type and the registered type. So for example, if I were to have a constructor that took in a weak reference messenger, the DI container would not know how to resolve that. Because I've told it that you can almost think of the first type as like if you were to look up something in that recipe book in say an index or a glossary. Weak reference manager is indexed under iMessenger. So it only will resolve it if somebody asks for an iMessenger. If you ask for this specific type, I would end up having to do I'd end up having to do something like this. You could actually think of this as or that's the wrong one. You could actually think of this single generic parameter as shorthand for having the double generic, where the first one in the double generic is the registered key of what it will be used to look up from, and then this being the implementation. If you have one, it just uses the same value for both. Great, simple. That's just nice, convenient shorthand. But in this situation, this is one of those cases where you would then want to make sure that you were passing in the same instance to both of these, because these are two separate registrations. So that's fun. This is another case where oftentimes I might do something like register like this, and then do something like this for shorthand. That way, both of these two registrations, even though they're registered under separate keys, you can think, again, separate items in like a glossary or an index. Even though they're under two different listings, they're both going to go back to the same place, rather than going back to different instances. So making sure that if you do register something under multiple keys, that you do it that way. This can also happen if maybe a single type implements multiple, maybe disparate interfaces. And so you want to register it under two different interfaces so that people, if they so I may end up getting this messenger if I ask for iMessenger, but I also may end up getting it if I ask for, my iSender or similar. So I think iMessenger is a composite anyway. What do you think about property field injection or same stuff? Some DI libraries provide those functionalities. Yes. So I think it depends. They serve a purpose. And confession time, I've actually written my own DI library that does support property injection as well. So there are definitely use cases where it is nice. Effectively, property injection from the DI containers perspective isn't that different than this. Like from the outside implementation, all it does is instantiate the object and then call the appropriate setters for you, which is great. I don't necessarily have a problem with it. The only thing to keep in mind is oftentimes there's sort of an implicit coupling there the moment you start using those types of features, because if you were to ever move away from that DI container to a different one, and the new DI container didn't support that same stuff, you now run into a problem where parts of your app may be broken in very non-obvious ways, because something that was previously magically handled for you is no longer magically handled. But practically, you don't usually change out your DI container that often. I mean, I've been on apps where it's changed once, maybe twice over years, so it's not exactly a common thing that happens very often. And anytime you do it, you're kind of ripping out a foundational piece anyway. There's oftentimes a lot of testing that goes into making sure that things are still working anyway. So yeah, I don't necessarily have a problem with it. The only thing I would say is if you're using it, make sure it's obvious to the programmers on the team that that is a thing at play, because some DI containers, it just works by magic, and it can be very counterintuitive to a new developer on the team that, how did this property get assigned? It just poof, showed up. I say that, and I'm also very guilty of it. My DI library does IL manipulation to make magic occur. So that said, I'm definitely on the guilty side of that. But yeah, I have no problem with some of those things that the third-party DI libraries provide. There is often good use cases for them too. Like Microsoft, for their one, they were like, performance is our top priority. Everything else can come in second. So they made theirs really fast at the cost of features. And other people are like, but I want the features. Okay, sure. You pick which one makes the most sense for what you're doing. Startup time on a WPF app is not overly significant, especially if you've already got some startup work that's happening. Maybe you're popping a splash screen already, adding, a half a second, not a big deal, and away you go. So maybe it matters, maybe it doesn't. Like a command line app, startup time, really significant. So, okay. Okay, so the other thing that I had broken is I did something bad here. This snack bar message queue. And this works by accident now. So if we start this up, so what is not obvious from just this code here, and I'll pull it open and show. So this now works magically, and again it works kind of by accident. It fell apart when we had this code in here, because this parallel for each, this delegate was going to get invoked on background threads. But now the only place where main window view model is actually being created is on an STA thread, so it works. And the reason it's problematic is because if we look at this snack bar message queue, I only know this because this is coming from the material design library. So this guy down here is, where is it? This guy. He's looking for a dispatcher, and ultimately, to get a dispatcher, it's looking at the current thread. So it's got this helpful constructor, which is great. It lets me instantiate it inside my view model, but it's only going to work if my view model is created from a UI thread, which isn't great. Isn't great at all. So, but you'll note it very helpfully has this guy right here, right? So this is convenient. It has a snack bar message queue. So let's come back here and let's change this guy up a little bit. So rather than this being a hard instance, we're gonna do that. We're gonna use the interface instead, because I'm pretty sure the interface is fairly thin. Yeah, it's just got a bunch of enqueue methods. We could actually even make the interface thinner with extension methods, but I'll add that to my backlog. But let's come down here. So now we're gonna go here, and I'm gonna put it up at the beginning. Because snack bar message queue. Okay, we'll do that. Autocode, can you figure it out? Oh, nope, can't figure it out. We'll go with, what was it? Oh, it did find the right one. I just thought it got the wrong one. Okay, I'm sorry, IntelliSense. I didn't realize you were smarter than me. Okay. Okay, and there's this guy here. Now, in this case, this snack bar message queue, this is something that I would not want to necessarily register as a singleton, because this queue is expected to support a single snack bar. So in this case, especially if somebody else in the app decided they wanted a snack bar control, for the material design library, that's just a little message that pops up at the bottom. In this case, I'm just using it for when errors occur as a way of, I don't like the intrusive dialogue for errors. I find those obnoxious. But in this case, it's still, you want to notify of problems. So we will go that route. So that means down here on my services, what I want to end up doing is I want to do a services add transient, and I want stack bar message queue, and I think what we're going to do here is we're going to we'll include the WPF library. We will go. I don't even think we need a full-fledged provider, so we're just going to underscore and discard that guy. Boom. Snackbar grabs the synchronization context of the main app. This allows the components to interact. Yeah, so this is one of those areas where it's not a great design in the material design library. The snackbar message queue it requires, because it's going to directly interact with the snack bar, specifically rather than having the UI respond to events from it actually deals with the timing of, okay, when do I pop the next message? Because there has to be some sort of waiting. Like if you queue up a bunch of messages in material design, you expect the first message to come up, wait for a little bit because the user might interact with or move their cursor over it or click on it. So it needs to be able to pause and wait if that happens, and then dismiss and bring in the next one. And then there's extra functionality built in there about, okay, if I queue up the same message 3 times, do we show it 3 times? Do we consider those duplicates and dedupe that as things go in? So it's got all that kind of functionality in there. So the only reason it's grabbing that synchronization context is because the implementation in the material design library, like it's an interface, but it's an interface that's really only expected to get the materials design one if you're in a real app, because the real one is going to do interaction with the control directly, expecting to be able to use it. So what we are going to come down here and do is, let's see, we're inside of a static. Yeah, so let's do, how do we want to get a dispatcher back out? Because ultimately what I'd like to do is I would like to grab a, so we'll write it this way. Dispatcher. So we'll just pretend like we got one. And then what we're going to do is we will do dispatcher invoke. And then we will do new snack bar message queue. So you want to be careful with dispatcher calls in your DI container like this, especially with transient things, because that can bite you. That can be bad. But yeah, most of the time you should be just fine. In this case, as long as your constructor is cheap and light, which this one is, just because this guy needs it. And I think what we're going to do, we're going to be explicit about the time span, because if we're going to retrieve the dispatcher, I think what we're going to do, we can actually we don't even need, we can be more clever. We don't need to do dispatcher invoke here. That's better. Let's do this. Because the only reason it's needing to go after that synchronization context is to get the dispatcher. But if I already have an instance, let's just pass it in. Time span from seconds. What was it? Was 0.3 the default? 3 seconds is the default. I guess that makes sense. Got to give the users time to read. Okay. And so here, what I think I'm going to do is I am actually going to do, let's retrieve this provider. Provider get required service, and we are going to pull back the dispatcher out of it. Now, currently, nothing's actually registered the dispatcher, so when this callback gets invoked, this is going to throw. So we need to fix that. So let's go with services add Singleton dispatcher. But in this case, the way we want to actually get this is going to be application.current.dispatcher. We'll just retrieve it that way. Simplify member. Oh, right, because I'm inside of the application. Okay. I understand that I can omit the generic parameter, but this is not clear to me. We're leaving that there. So now I should be able to recreate my main window view model, because my main window view model needs this snack bar message queue. This guy needs the dispatcher. Dispatcher's registered here. Okay, so that should work. And then let's go down here. Do you do leak code? I have in the past, but it has been a very long time. Can we rule the dispatcher in regular tasks or control the dispatcher priority to allow him to manage to all? So, yes, you can. I'm pausing on that because I don't think that's actually the structure you want. Let's get to doing the task.run case, and I think that will probably show a cleaner approach to handling that. So, but let's make sure our snack bar message stuff still works. Okay, so we launch. I just realized that even though I launched, we haven't done it. Hello, Milo. Was there something specific about leak code that you were interested in, or just looking for people who do it? Let's come in here. I want to just validate. Did I? Oh no, I did validate. I couldn't have gotten a no, so it did resolve my instance. Okay. Okay, so let's talk about this task run, because I assume this is part of what the question comes to. There's oftentimes this struggle inside of WPF related stuff, because there is a rule with almost all UI frameworks that says only the UI thread can touch UI elements, and if you touch it from a background thread, you get your hand slapped, exception, things crash. It's not a good day. So we've registered the dispatcher inside of our DI container, so there's nothing stopping us from accepting it as a constructor parameter. That's a thing we could do. The reason I'm hesitant to do so is the dispatcher I will often classify as a UI class, and in general, you don't want to get your UI classes pushed down to any of the deeper levels below the UI itself. The climbing stair problems. I know it's easy. I just can't understand the solution. I will admit I am not familiar. Let's see. I assume this is what you're referring to. So slight detour. And welcome, by the way. You're climbing a staircase. It takes n steps to reach the top. Each time you can climb either 1 or 2 steps. And how many distinct ways can you... Oh, this is the game... What is the name of it? Oh, I've seen this problem worded in a different way, where you and an opponent are pulling matchsticks out of a pile, and you can pull either 1 or 2, and you need to and you don't want to be the guy who picks up the last one. So there's a similar algorithm that immediately jumps out to me. It's got a short name, Mim. Oh man, I'm blanking on that name. You can either climb 1 or 2 steps, and how many distinct ways can you climb to the top? So if n equals 2, the output is 2, because you can either go up 1 step at a time or just jump both steps. Got it. Okay. I know it's easy, I just can't understand the solution. So in this case, it's asking for identifying the count of the permutations. So how many different solutions are there? Trying to think of an easy way of putting this down. So in this case, there's kind of a cheater way to do this with binary, but it doesn't expand out very nicely. But so rather than doing 1 or 2, you could count it as 0 or 1, and then you can kind of quickly find your way through in that case, because you can start to see the count out of how this is going to end up. Because whatever n is, the very first solution will be always just go one step at a time. 1, 1, 1, 1, 1, all the way up. So n of 45, the very first solution will be jump 45 times and then do it. With the next solution being go 2 steps at a time, then 1, 1, 1, 1, 1, 1, 1, all the way up to 45. And then you can shift that to over 1, do 1 step, 2 steps, then a bunch of ones again. And so you start to get a pattern that very much almost looks like if you've seen like the binary clocks where you see the counting, which is why I say because they're the limits on how many you can take are only 2 values, 1 or 0. You could almost do it in the same way that a binary clock counts, and count up from there. Does that help? I don't know if that's familiar. I'd be curious to know what your background is. When I say counting in binary, if that makes sense to you or not. I'm kind of getting it. So here, we'll write out just a couple of these of conceptually how. And again, I suspect there's multiple ways to solve this problem, and this is just the first one that comes to my mind. So other people can have different ways of doing it. So picking on their built-in sample. And by the way, I definitely don't mind getting distracted with questions. So we'll circle back to the DI stuff in just a minute. So if we pick on n equals 3, and 1 step will equal 0, 2 steps will equal 1. So where n is 3, the solution is 0, 0, 0. The solution is 0, what have they got? 0, 1, 0, and 1, 0. Because for each of these things, you end up, actually I guess we could, rather than doing this in binary, we can actually think of it like this: 1, 1, 1, 1, 2, 2, 1, and the result is that all of these things summed together must equal 3. Right? So if we go up one more beyond what they have there, so 4, it would be 1, 1, 1, 1, 2, 1, 1, 1, 2. I missed 1, 2, 1, 1. Let's see, and then we increment one more time, right? Because that adds to 4, that adds to 4, that adds to 4, and then 2, 2, I believe, is the next one. I believe for n equals 4, that's the total number of solutions. So in terms of, if I was to write code to do this starts to look to me like a recursive algorithm a little bit, where you start with all 1s, then you add in a 2, work it forward, add in 2 2s, work it forward, and actually let's go n equals 5 just so that we can see the process of adding the second 2 and working it forward. Right? So we start here, so it's going to be 1, 1, 1. I think this one then becomes that. So you can kind of start to see the pattern. As we bring in a 2, it kind of walks all the way down the line. Then we bring in a second 2, and then this goes 2, 1, 2. right, and then 1, 2, 2. I believe that's all of them there. So, and the interesting part about this algorithm is, unlike a lot of normal counting where, like in base 10, if you're just going to count up to 100, you know that you're only going to have those 2 digits up through 99. Whereas this, because the total is shifting, you're losing digits basically as you're counting out the solutions. So oftentimes on some of these, I like to go through and just start doing out the smaller numbers that I can brute force. Because unfortunately with like N2 and N3, they're fine examples to explain the problem, but I think you have to go out to 4, 5, maybe 6 before you start actually seeing the pattern to it. Because once I start seeing this pattern, I can now start imagining what my for loop is going to end up looking like to kind of do this, or what my recursive function might look like in order to go through and do this summation. So hopefully that helps. Hopefully that helps a little bit. Okay, task run. Okay, so static methods are a pain in the neck. Oh, thank you for the follow. I appreciate it. Specifically with DI, statics are a huge pain. But there are a few statics that are in and put an interface to another library to allow us to untie the consumer to get only an interface. Yes. I will let me show that with the dispatcher. Yeah, I'll show a quick implementation on the dispatcher. Public interface, and I've seen this written a number of times, right? And so you could have something like, what is the invoke signature? Dispatcher invoke, right? So it's just void action. So we could do void invoke, take in an action, right? And the only drawback is we can't put our own interface on the actual WPF dispatcher class. So what we end up doing is usually wrapping it, right? So no. So this guy ends up being public class my dispatcher, and then usually you do something like, so this class exists simply for store and forward. It's literally all he does. Dispatcher, right? And then this guy, dispatcher, not disposable. Those are different. Implement interface, and then this guy literally just forwards on. Right? And you can imagine a similar pattern being applied to any number of things. That could be in disparate libraries, that kind of thing. It's actually not uncommon to do this, especially on libraries that have some class that you'd like to register in your DI container, but it doesn't have a reasonable interface, or their interface sucks and you want to clean it up, or similar, right? Like this kind of pattern has its use cases. And you can certainly do this. And I've seen people register it, and then your view model takes in an iDispatcher and it's got access. Everyone's happy. The one thing I hate about this, and this applies in a lot of different situations. My comment earlier about interfaces are easy to write, but hard to get right. There is a general architecture pattern called a leaky abstraction. And what it means is oftentimes your interface leaks out the details of the implementing class behind it. In this case, it's not horrible because it's only leaking this out. But usually the moment you start to write a second implementation of an interface, that usually starts to tease out those bad abstractions. Because if you have to put a method on an interface and then only implement it in one or only in some of your implementing classes, that's probably an indication that your interface abstraction is wrong. Because once you start getting those tight couplings of, well, this method only really applies to this implementation, it's like, okay, but if you're exposing that out of your interface, you're saying all implementations should match that. And so you start to get into that situation, which is another reason why writing tests over your classes really start to help tease out those things. It's also a great reason why on that testing video I posted earlier, why the last step that I advocate for is writing your own implementation of the interface as a simulator, because by the time you've done that, you've probably teased out a lot of those potentially bad abstractions. And that's the only thing I don't like about iDispatcher, is it tends to be a leaky abstraction. With that said, I'm pretty sure I've added this exact interface to multiple projects. So if you can get away without having your code depend on the dispatcher, that is preferable. So ways to avoid it depending on the dispatcher. Do I have a good example buried in here? I don't know if I do. So, for example, if the other way we could have handled the snack bar message queue, since this is a UI object, is this thing is only being used inside of the view model for showing error messages. So you'll know when it goes to show an error, all it's doing is putting a message on that message queue. And let's assume that the snack bar message queue didn't have an interface on it that we could use. We could wrap it up and put our own interface on it. That is one option. Another option would be to actually leverage that the messenger, the pub submodel, to decouple those things apart. So rather than having show error directly at it, do something like messenger send new. This is total pseudocode, so show error message. Stop helping me. Details. So we could have it just post a message, and then in our code behind, create our snack bar message queue here. And there's no reason this guy couldn't also be a recipient for that message, and have the UI object say, oh, okay, when you want to show an error message, what that means is I put it onto the snack bar. Great. Now all of the code that's using UI objects lives in the UI. Or, hey, I need to make sure that because I'm touching a UI object, when I receive a message, I should probably make sure that's invoked on the dispatcher. And so oftentimes what I'll try to do is, rather than getting the dispatcher down inside of view models or service code to get access to have them use the dispatcher, my preference is usually to have those objects post messages or similar out, and let the handler then decide, oh, does this need to be on the dispatcher or not? Because the other thing that oftentimes happens is if you do like dispatcher invoke, you're making the assumption that the code in your view model now knows something about your view. Because anything that you put in that dispatcher invoke, inherently what you're saying is, I know this has to be on a UI thread. Well, by having that, if you have that knowledge about a UI thread down inside your view model, you've kind of exposed a little bit of coupling there implicitly by having that knowledge. So again, I usually try to keep the dispatcher as close to just being in my view objects as I can get. That's my preference. I don't doubt that people can probably find use cases where just passing it down makes more sense. I would totally believe that those cases exist. But I would also look to restructure first. That wouldn't be my go-to solution. Okay, and a similar thing actually can be applied to this task run. So in here, what we've got is this load themes problem here. And what we want to have happen is when the window is shown, we would like to actually kick off loading the themes. And so one very easy way to handle this, we're going to get rid of that. If we have a multi-library app, we need to be more careful about types. Without interfaces coupling, one library can get unnecessary references. Typically, that doesn't end up being too big of an issue. So you always have to be careful about coupling. So that is always something to be conscious of. Usually the easy way to work around it is, if you see the number of things in your constructor getting big, start looking for ways of refactoring your objects. View models are no different than any other C# object. All the general good practices about, hey, try to keep your methods small, try to keep the number of your dependencies small, all of those things, because smaller code is usually simpler code, easier to read, easier to refactor, maintain, etc. Again, those are guidelines, not hard, fast rules. All of those things apply. In the multi-library approach, I don't think it changes too much. You usually don't end up with unnecessary references, but you can accidentally add coupling where you don't expect. I highly recommend unit tests, because unit tests typically tease out where you've got coupling. If you go to start writing a test over an object like this main window view model and it's hard, evaluate why it's hard, because that's probably starting to hint at a structural problem of coupling or similar. Should we strive for module applications where the modules don't know each other? I will answer that abstractly. Yes-ish. So that is good on paper, and oftentimes what I try to do. So if it is possible to have things, I will say this: you should try to reduce the amount of coupling you have. The other one is that you'll hear people talk about with coupling is cohesion. So the golden standard is low coupling, high cohesion. So if it is reasonably possible to break things apart, do so. But there is an extreme to that. So even though that is good, and I think I like the word strive there, it is a good thing to strive for, but there comes points where you shouldn't. It becomes overbuilt at a certain point. So because you can refactor and decouple, and oftentimes decoupling is great, but with all of those abstraction layers, you can oftentimes make your code worse, because now it becomes really difficult to work with. So there is an extreme, and I would say don't push it all the way. Again, I like tests for handling that, because they start to tease out where those layers should be. Okay, I'm gonna deal with this task run real quick. So this guy is pretty easy, because in this case, I'm just gonna make this guy public, because I have no problem with this guy being public. Or actually, I don't even need to make him public, because he gets invoked from the refresh command, and the refresh command is public. So here's what I'm going to do. I'm just going to get rid of task.run out of the constructor. That just goes away. And then I'm going to go into my main window, because ultimately what we're saying is we would like the themes loaded when the window launches. So I'm just going to go down here, register up a loaded event. And so when the main window is loaded, we're just going to go view model dot refresh command execute. Yeah, I like that. I like that a lot. Boom. Oh, and it wants a parameter, but that command doesn't take any parameters. So we're going to do that, and that should get rid of that ugly bit of stuff in our constructor. Let's first make sure our app still launches and works. Boom. So it's still loaded everything up. That's great. What we might do here as well, I won't worry about it. Should we unsubscribe from events like loading button click? Can GC clear unsubscribed objects? Oh, that is a wonderful question. So that is specifically tied back to this loaded event. So this is one of the best and worst things about C#. Latest versions of C#, they have moved towards making code easy to write. And so oftentimes the latest versions of C# hide away a lot of the ceremony. So I'm going to write out what is actually happening here. Routed event handler. So when you type plus equals on the event, what it's actually doing is instantiating a new delegate type and pointing it at a method. Not that uncommon to what we did when we created a delegate here. So in this case, what is happening is the main window is getting, its loaded event is getting registered to a method here. And what is subtly happening is because this is an instance method, this is capturing this variable. So this event will have a reference to this method, as well as holding on to a reference of main window. Now in this case, we're fine, simply because it means main window is holding a reference to itself. And the garbage collector in C# is top notch. It is amazing. Highly performant, but it doesn't mean you can't do really bad things with memory. And event handlers, when people have memory leaks, they tend to be a big culprit. So knowing that when you do plus equals like this, that it is implicitly capturing the reference to your current object, that's really, really important. One of my colleagues actually made a statement a couple weeks ago that oftentimes events, if you're writing a custom event, you're probably doing it wrong, because using things like the messenger is probably a better solution in most cases. But events still serve a purpose. They will never completely go away. So it is important to know this, and so you do need to be conscious of when you need to unregister. So in this case, the loaded event exists on the window, and the window is capturing a reference to itself, which from the garbage collector's perspective, that's fine. When the window isn't referenced by anything else, that it's not like it's reference counted. It will collect objects that are basically in a big ball. If there's no reference linking back to the root, that whole branch of objects gets consumed by the garbage collector and cleans up. Where things start to get weird is, say we pass in an object and we do like view model dot property changed, and we start registering up. Right? So now things start to get a little more interesting, because now what we've done is the view model is going to have a reference to the window. So this is now a bit more problematic, and this is why two lines of code that look very similar, right? Very similar lines of code. This second one is not problematic because it's the window referencing the window. Okay, we're good. Those will get cleaned up. In this case, the view model is now capturing a reference back to the window. So these things will only be cleaned up together. Now in that case, or I should say, in this case, we'll be fine, because I know that my DI container is registering those as Singleton. There's only going to be one instance of each of those. The app shuts down after the main window terminates, yada yada. But that's not a generalized statement that I can apply to any other apps. Because of outside knowledge, I know that's fine. Normally, if you register up an event on some dependency like this, you want to be very careful that you appropriately unregister it as well. Because otherwise what will happen is this view model is holding a reference to this window now, because this is this dot. So if we register a loaded event in, for example, nested button instances down in the tree. Yeah, so in those cases, if you are registering for it depends a little bit on where you do the registration, but most of the time those will be just fine that you won't need to unregister for. So like click events on button handlers and that kind of thing. Those will be just fine. Simply because, in my opinion, unless you're doing something fancy inside of your app, typically those buttons, the time when you want those to be garbage collected is when the window is closed. Because oftentimes when the containing control is done, they can go away as a unit. Now there may be times where maybe you're doing some fancy dynamic swapping of UI stuff. Maybe that isn't always true. In that case, you might want to pay attention to it. In general, if you're just registering for like button click handlers, and the place where you're doing the registration is inside of its container, like inside of its window or inside of its user control, etc., you'll be fine. Because as soon as that container has no outside references referencing it, that whole chunk goes away as a unit. Because again, the garbage collector, if there's nothing, if no references linking it back to the root of your app, then it dies. You can think of it, if there's nothing that links it back to anything inside of main, it just gets cut off. So if it can't find a reference chain through the instances back to main, that whole branch gets cut and garbage collected and thrown away, which is good. That's what you want. You don't want to get into those cases where, like in other languages where you have to manage your memory or do like reference counting. Circular references in ref counted languages get to be an interesting problem to solve, because if A references B and B references A, they both have a ref count of 1, they never get cleaned up. In C# with garbage collecting, because we follow that tree all the way up, we can just say, no, even though they reference each other, there's there's no references coming into that group, we just get rid of the whole group. And so it just goes away. So in that regard, we're fine. So, okay. Oh, well, that was disappointing. That was disappointing. 1 second. I just spilled some Mountain Dew. Thankfully, not on anything important, but I now need to do a small amount of cleanup. This is true only for routed events if we declare on C# events. So no, not just for routed events. This applies to all any C# event. So anything where you're using plus equals to register up for, that will apply to it. So the key thing to look for, sorry, you got to get the Mountain Dew up before the sugar leaves a nice sticky residue on everything. When you are registering for an event, just be aware of what is going to be captured. So when you do plus equals on the event, what actually gets built up inside of this is the instance, as well as what's the method info. It's the system reflection object that denotes how to call one of these methods. The other thing to note, so this one right here is capturing this variable of the window. However, it won't capture that. It's the static method. So you'll note before, when I had this dot in front of it, it was perfectly fine to do the registration because it was capturing this. But now that it's static, it wants me to drop it. And this just comes from the fact that C# doesn't make you do all this typing, which is great that it doesn't make you do the typing, but it means you need to know what's actually going on when you compile this, because it will, because it's going to, even though the code has the same characters in it, it will do different things. So that's worth knowing about and keeping track of. So if we declare our own custom click event and another control subscribes to it and don't unsubscribe, can GC erase it when the control is unloaded? So it depends. Maybe. If the other control is inside of it, then I would say you don't need to unsubscribe from it, and you can just assume that those things are going to go as a unit and go. It does depend on where that other control is and how it gets a reference to it. So typically in WPF, you don't usually have problems of one control reaching and grabbing a control that's kind of outside of its context. However, there's nothing stopping you from using like the visual tree helper and just walking up and down your XAML, finding a control, grabbing a reference, and registering up a click handler on it. There's nothing stopping you from doing that. But that would be the case where I would be a lot more conscious about, do I need to unregister? The other case that often comes up where it can leak is in like behaviors. With WPF, if you've done any of those like attached behaviors, those can sometimes people will register event handlers there and those can leak. So I would say in general, if you are registering on a UI event or an event you create on a UI object, you could pay attention to what the owner object is, because when the event is invoked or raised, what has to happen is the runtime has to know where those handlers are to go and invoke them. And so if those methods are instance methods, in order to invoke this method, it needs to know the instance to invoke that on, which is great. That's exactly what we want. I need to know what instance to invoke this method on. If it's static, I don't need an instance. In fact, I can't have an instance in order to invoke it. So I think all I would suggest is when you do a plus equals on an event, just evaluate what the owner instance is, if any, because again, if it's static, there won't be an owner instance. And if that is problematic, so for example, if I do, and sometimes it helps to type this dot in front of the event, because if it's static, you'll get a compile error telling you, hey, this is static, it's not actually going to capture it. And if it's an instance, it'll help you kind of reason about, should view model have a hard reference to this variable here? And even if this method is on some other object, right? Other dot method, right? Should this guy have a reference to this guy? Will that be a problem? So if this is a UI element and if this is like a parent UI element and this is a child UI element, probably not an issue, right? When the window closes, oftentimes, unless something is holding a reference outside of the window, if all the things that are holding references to the window are inside of it, like their child buttons and that kind of thing, no problem. Garbage collector will take care of it. But if there's something outside of the window that's holding a reference to it, well, now you have a problem. Specifically, the common leaky case is if the outside thing comes in via your dependency injection container. So because your dependency injection container, anything Singleton, it's going to hold on to those references for the whole life of the application because they're single. I should have one and only one. But that also means any references that those singletons acquire, they don't let go of unless you explicitly let go of them. So I hope that answers the question. But good question about events, because this is events are often a prime source of memory leaks. Oftentimes when people track down UI interactions that are causing memory leaks, the first thing I do is just look for event handlers, because very, very often that's where things are. The diagnostic tools are also gold for tracking those things down. Okay, so real quick, how to determine when user control is really deleted. Unloaded fires, seems we can't see the element. So I assume by deleted you mean garbage collected. And that's a fun one. So there's a couple things to understand. So first of all, one of the, I will say, quote unquote, problems is C# does not have deterministic finalization, meaning there is no way for you to know exactly when a control will be deleted or cleaned up by the garbage collector. You can, so there is a destructor that you can declare. This is what, if you declare a destructor, so this is a little tilde right in front of the class name, this will get invoked when the garbage collector is cleaning up objects. And there are some absolutely horrible things you can do with this, like resurrect the object, which you should not create zombie objects, but you can. You shouldn't, but you can. So if you just want to know when an object is being cleaned up via the garbage collector, you could do something like this. I will caution on writing destructors though. There is a performance hit by doing so, because now your garbage collector has to stop and invoke these methods that previously it didn't have to do. So there's that. Yeah, not recommended to use a destructor at all. And the other thing is, even once you're inside of a destructor, you can't actually guarantee, because the cleanup isn't guaranteed to be in a particular order, you actually can't guarantee that the references stored inside. So for example, this view model, right? Normally I would expect this is a read-only property. I know it wasn't null when it came in, right? But it is actually possible to get into a situation where in here it's null, because the garbage collector could have already cleaned that object up. Because when the garbage collector gets a group of objects to clean up, those get thrown into a queue that get processed, and you can't guarantee where in that queue you are, which is another reason why a destructor is really discouraged. The only useful part for this is if you're dealing with unmanaged memory. This can often be needed to make sure that you clean up unmanaged references. So if you're referencing like a C++ library or similar, where you need to make sure you get stuff cleaned up, that's the use case for these, is usually unmanaged stuff. In C#, if you do need to make sure that you know when an object is done or cleaned up, you would use the iDisposable interface, and I will just so there is, I think this one has all of the docs on it. Yeah, and the iDisposable docs are very good. This is typically when people want to know when an object is cleaned up, this is the way to do it. You'll note there's a lot of description in here, and the proper way to implement iDisposable can be quite complicated. So complicated, in fact, that Visual Studio 2022 now has a nice built-in option to do it for you. Highly recommend this. It will steer you into the path of success. So if you do decide that you want to make sure that you know when an object is, and I will clarify, this isn't necessarily garbage collected. This is disposed, which is not quite the same thing. So no, don't just implement interface. So this will give you this pattern, and you'll note it comments out a destructor, which is different from a deconstructor. Anyway, but it's worth noting that that you only need this if you are freeing unmanaged resources, and then the pattern of how to know where to dispose where is this. And so then the question of who invokes disposing. So for example, I just made the window disposable. So if you make something iDisposable, what would then happen is that's what the using statement in C# leverages. So view var window gets new main window, right? So we're gonna do this is horrible, but we're doing it anyway. So, and I'm going to use the specific using syntax. So when you write a using statement like this, the compiler has special support for this iDisposable pattern. what this ends up doing is building out something that looks not exactly like this, but it looks kind of like this. So when you write out this using, what the compiler under the hood ends up generating for you is something like, let's see, main window, oh, I have to change the name of it, window 2, right? Window 2 dot dispose. So it looks something. Again, this is not perfectly accurate, but it's close. Window 2 gets new main window. Boom, boom. So ignore the warnings. Something like this. Using block here. So the short version, what ends up invoking dispose is typically usages of the using statement, and there are coding analyzers to flag you if you have an iDisposable object that you don't put in a using statement. So worth noting that if you do want to say have an object where it allocates a bunch of stuff, but in our case, when a control is deleted, he can live, I assume live half a day. But in our case, when is the control deleted? So the easiest thing to do is you likely don't know, and you probably don't care. So, and I'll phrase it that way. So the garbage collector doesn't. It has built-in heuristics to know when should it run. So oftentimes, because when the garbage collector runs, it ends up freezing your app. So you want the garbage collector to run as fast as possible and as infrequent as possible. Those two things can often be somewhat conflicting, but because it can't necessarily work. And I'm going to put a little star next to it because recent improvements have made this not true. But it can't realistically work trying to clean up a mess if your app is still busy making a mess. So oftentimes it pauses you, cleans up the mess, then lets you go again. There's some fancy concurrent garbage collection stuff, and here are lots of docs. C# garbage collection. There is. Yeah, there is a lot of depth here. In your case with using, it creates and deletes at a time. Correct. So in this case, I shouldn't say it deletes. It creates the window, calls dispose, but I don't actually care when it gets deleted because it's going to allocate some memory for my window. And then when this thing leaves scope, so even if I did this, even without the iDisposable, I'm going to instantiate a main window object. It's going to live. I'm going to fall out of scope. And then no one's holding a reference to this. So this is going to be memory. If you're familiar with like C programming, this is going to call malloc. It's going to allocate some memory for my main window. It's going to live. And then once it falls out of scope, because no one's holding a reference to this, even though that memory's been allocated, at some point, something needs to deallocate that memory. And this is where the garbage collector comes into play, where at some point in time, it's going to run and realize, hey, there was this variable that got allocated. No one's referencing this anymore. This variable is now out of scope. That memory that got allocated, that's available to be reclaimed. And that's what the garbage collector will end up doing, is deallocating that memory and taking it back at some point in the future. You can, if there is a point where you want to actually try to get cleanup to happen, like for example, if I know that this view model is really big and I'm all done with it, and I kind of want to hint to the garbage collector, please go clean this up, I can break my references. So simply no longer having a reference to that instance. So I throw away that instance, and we're going to pretend that the DI container isn't holding a reference to it. But we break our references to it, and then you can tell the garbage collector to or I should say, you could force an immediate run over it, and try to tell the garbage collector to run. This will make it go. It won't guarantee that you're cleaned up. So we have no way to find out if the control was removed to sum up. No way reasonably in code. What you can do if you are on Visual Studio, or there's various other tools. So for example, am I debugging? I am not. Here, I'll show this. So there's a, if you poke around online, you'll find various memory management tools. I'm gonna clean up some of this code real quick before I do something stupid like leave it in. Because if what you're interested in tracking down is, hey, has my control been cleaned up? What you can do, so we'll start this app up. So these are this is just the basic diagnostic tools inside of Visual Studio. I believe this is only Visual Studio Pro and Enterprise though. If you're on Community, I don't think it has this tool. Don't quote me on that. I think that's true. I sometimes forget what's available in different SKUs. So the important thing to note when the app is up and running, oh, stay big, is, where did it go? There. Is this process memory. So this is the stuff that's been allocated, and everywhere where you see one of these little yellow things, this indicates that was a GC. That was the garbage collector going through and cleaning stuff up. So you can see right at the beginning when there was a bunch of allocations, likely stuff being created and destroyed, things got cleaned up fairly rapidly in rapid succession, and then we got out here and we're pretty stable. In case if we want to know and wait when the control is deleted to run some stuff, I would propose that you probably don't care about when it's garbage collected and only care about when the control is no longer in your view. So in that case, I would propose that what you are really looking for is like the unloaded event on your control. But in terms of memory usage, what you can do is take a snapshot, which this will look at all of the objects that are allocated, and you can see them here, and that's great. And then we can do some stuff. Like I can open this up, and you can see when I open the pop-up, there's a little bump in memory. And what I'm mostly interested in is a small bump in memory is fine because I'm now doing stuff. But what I don't want to see is it continually go up. No longer in the view doesn't mean that the control is deleted. Correct. I guess the question is, I would be interested to understand why deleted is the case that we're looking for. In general, in C#, you usually you don't usually care when an object is deleted. You may care to do something after it's been dereferenced. So like after you've nulled out all your references to it. But in those cases, you typically would leverage, in those cases, because you're saying an object has a defined lifetime, you would oftentimes use iDisposable. If it's a WPF UI object, you would oftentimes use like the unloaded event, or if it's a window, the closed event, to know, okay, this thing is now unreferenced. Because at that point, the item is cleaned up, and then if there's some sort of like shutdown or similar code, that's when you would typically go and run it. Usually. So, but it's somewhat rare to need to run code after an item has been, and I almost don't like the word deleted. Deallocated might be a better word. Because controls aren't necessarily deleted. They're allocated in memory, and they are deallocated from memory, which I've been equating deleted and deallocated, and perhaps that's not the appropriate thing to do. If if I'm misunderstanding the question, let me know. Anyway, so pop up, I took a snapshot, you take a second snapshot, and then usually what you do is you compare these two snapshots and look at and say, oh, okay, so between these two snapshots, I've allocated an additional, what is that, 2.3 meg, give or take. And then you can start to dive in and figure out, okay, what are the differences between these? We should not worry about the elements when they are removed, should rely on GC. Correct. The one thing you do have to keep track of, though, is making sure that you have appropriately broken all of the hard references that you think you have. So that is the one thing in C# to very much keep track of, is making sure that you've cleaned it up. Thank you for the answers. Very interesting talk. No problem. Like I said, I enjoy questions, and I don't mind rabbit trailing off on other things, especially if something leads into questions about it. So, I think I am probably going to wrap up for the night, though. I was going to do some of the testing stuff with this, but I might leave that for another talk. So if people are interested in so we've gone through and talked about DI and structuring our classes, and this is all well and good, but one of the main reasons for doing this more loose coupling of the application is to make it more testable and easier to refactor. So I initially wrote this app quick and dirty with lots of coupling because I wanted to go fast, and that is how you go fast. That method is just really bad for refactoring and really bad for testing. So anything that needs to be maintained long term, probably don't want to do that. It tends to add a lot of tech debt that you end up having to pay back with interest. So I think I will probably end up doing a structure on testing if people find that interesting. But definitely send me comments, either in the chat or actually, if people haven't figured out my URL scheme yet, it's pretty simple. But yeah, feel free to drop me feedback. I've appreciated it. Everybody who's left comments so far on the videos or message me directly with ideas. I do keep a running list, so if there is stuff that is interesting to people, oh boy, Justin Bieber, you are on fire. I'm gonna switch this here real quick. So let's see, more about yourself, education, programming language do you know, WPF client architecture, multi-library applications, useful programs in your opinion for programming stuff. This is great stuff. About one applications, unit testing, essential. This is okay. Once again, I'm going to just, all of this is getting copied and pasted right onto my Word document. So perfect. I will keep this stuff coming. For people getting started, actually, hang on, let me switch back here. This is shameless plug. Essential C#. So there is a book put out. Essential C# by Mark Michaelis. Let's see. Open image in new tab. For those people who can't see it, shameless self-plug. I was one of the technical editors, so if I am a little biased towards it. But if people are interested in a C# book, I will comment. Its intended audience is really for people getting started. So it is chapter 1 is everything basic hello world. So if you haven't written any code and you're just getting into it, this is expected to take you from almost nothing all the way up to competent in C#. So just be aware that for some people who have a programming background, some of the early chapters may feel like they move slow, but it is fairly in depth. It is pointed at C# 8, so it does not have any of the C# 9 or 10 features covered inside of it. So there is a potential for a electronic copy that may or may not occur at some point, because we want to try to move some of the content forward for newer versions, but that is TBD, and not, I will say, not guaranteed. So if you are interested in a book like that, I can recommend it because I know the contents. I also have real copy too. So, but again, just be aware that if you're looking for C# 9 or 10 related stuff, you aren't gonna find it in there. So that is one of the things to be aware of. But yes, I will go through this. Color and naming, Visual Studio. WPFX. Donald Matthew. Cool. Yeah, I thank you for all these suggestions, Justin Bieber. I will definitely go through and do it. And again, if other people have feedback that they want to get to, or you're watching the recording of this, feel free to drop a line in the comments or similar. I am always happy to go through those. And like I said, I do keep a running list on stuff in here. So I've been trying to go through and do I don't know if educational content is the right word. We'll call it training related stuff. So I definitely I like sharing what little I know. But Set Pro, WPF, Windows Presentation Foundation, .NET 4.5. Yeah. So, and I will say this, with WPF specific content, there has been very little that has changed in WPF from .NET Framework through the .NET Core versions. There's only a handful of really tiny things that have even happened in there, and most of the time people won't catch them. So like there's a few namespace things and that kind of stuff. So even if you find an older WPF book, like 95% of that content is still going to be spot on with WPF today, even if it was written for WPF on .NET Framework 4.5. There's going to be a few, like some of the C# the C# APIs, if they reference the base class library, some of those there's going to be updated stuff on, some updated syntax things. But again, most of the content on WPF, and especially all of the concepts, are going to be pretty much identical. So I will say that if you find that people are recommending books that are older on WPF, their content is usually still spot on. So I would just disregard anything that has version numbers in it. So when they say install .NET Framework version 4 whatever, yeah, don't do that. Ignore version numbers, but the rest of the content's probably pretty good. Yeah, unfortunately, the Twitch chat does not do formatting well at all. So, well, thank you for coming and hanging out. Hopefully, people found this to be useful. And thank you, Justin Bieber, for all of the suggestions. And some of these things will start coming in. Yeah, so, and one of the common themes I've seen come up multiple times now has been around threading and async and await. So I may end up, that one may be bumping towards the top of the list. So I may end up doing that one sooner rather than later, and kind of discussing how all of that works, because that is a deep topic to dive into. So, but with that, I'll say thank you very much for everyone coming. Happy coding. Talk to everyone next week.